The cosmos hides more strangeness than any science fiction. We are embarking on a journey to uncover the 25 most bizarre objects ever discovered in the vast darkness of space. By the end of this exploration, you will know the universe is a place of endless, wonderful oddities. We will encounter a planet made of solid diamond and a star that behaves like a cosmic predator. What do you believe is the ultimate mystery waiting for us out there? Our journey begins with a cosmic scream, a signal so powerful it outshines entire galaxies, yet vanishes in less than a blink of an eye. Astronomers call them fast radio bursts. These are not gentle whispers from the void, but sudden, violent explosions of radio waves traveling across billions of light years. Their discovery was almost accidental, found by scientists sifting through old data from a radio telescope in Australia. One single burst can release more energy than our sun emits in 80 years, all compressed into a mere thousandth of a second. The sheer power is staggering, forcing us to ask what kind of cosmic engine could possibly be responsible. The leading theories are as dramatic as the bursts themselves. Some point to catastrophic collisions, like the violent merger of two ultra-dense neutron stars or the final, sputtering death throes of a black hole. Yet the very unpredictability of these signals, flashing once and often never repeating from the same location, fuels a more tantalizing possibility. Could we be listening to the leakage from unimaginably advanced technology? Perhaps a deep space propulsion system or a beacon from a civilization far beyond our own. The truth remains one of the greatest puzzles in modern astronomy, a brief and brilliant mystery written in radio waves from the edge of the known universe. If fast radio bursts are the universe's deafening screams, then the next object is its most profound silence. We are venturing into the Boötes Void, a region of space so terrifyingly empty it has been called the Great Nothing. Discovered in the 1980s, this cosmic desert is not just a patch of dark sky. It is a spherical chasm nearly 330 million light-years across, a volume of space so vast it could contain thousands of galaxies like our own Milky Way. Yet when astronomers peer into its depths, they find almost nothing at all. Where we would expect to see tens of thousands of brilliant island universes, we instead count only a few dozen. This staggering emptiness challenges everything we think we know about the cosmos. Our standard model of the universe suggests that matter should be distributed somewhat evenly on the grandest scales, like a vast cosmic web. The Boötes Void is a hole in that web, a gap so enormous it should not exist. How could such a colossal structure form? One theory suggests it might be the result of smaller voids merging over billions of years, like soap bubbles coalescing into one giant cavity. Another, more speculative idea wonders if it is an imprint from the very birth of the universe, a primordial flaw in the fabric of space-time itself. To truly grasp its scale, picture our entire local group of galaxies, a collection spanning millions of light years placed inside this void. From our perspective, the night sky would be almost completely black, a profound and permanent darkness with only the faintest, loneliest pinpricks of light from the handful of remaining galaxies. It is a cosmic ghost town on a scale that defies human comprehension, a silent mystery that whispers a daunting question. Are we missing a fundamental rule of how the universe builds itself? From the profound emptiness of the void, we now turn to an object of almost unimaginable density and wealth. Orbiting a rapidly spinning stellar corpse known as a pulsar, there exists a planet that defies all earthly concepts of value. Astronomers have designated it Pulsar J 1719-1438b, but its popular name captures its essence perfectly, the Diamond Planet. This world is not merely rich in carbon, it is thought to be a gigantic cosmic gem, a sphere of crystalline carbon so vast it could be worth more than our entire global economy countless times over. Its story begins with a dramatic transformation. It was once a massive star, but its outer layers were violently stripped away by the gravitational pull of its pulsar companion. All that remains is the star's incredibly dense core, a remnant compressed under immense pressure into a structure where carbon atoms have arranged themselves into a rigid, planet-sized lattice. The conditions there are as extreme as its composition. This diamond world orbits its pulsar so closely that an entire year passes in just over 2 hours. It is bathed in intense radiation, a far cry from the serene sparkle of a jewel in a display case. This celestial diamond is not a place for life, but a monument to the violent and creative forces of the universe, a glittering relic of a star's death that challenges our very definition of a planet. Yet even a diamond planet pales in comparison to the scale of our next discovery, a predator that roams the cosmic ocean. The Andromeda Galaxy, a familiar, hazy smudge in our night sky, holds a dark secret. It is a cannibal, a colossal island of stars that has grown vast by consuming its smaller neighbors. The evidence of this galactic feast is written in the faint, ghostly rivers of stars that swirl around it. These are stellar streams, the torn apart remains of smaller galaxies that ventured too close to Andromeda's immense gravitational pull. Over billions of years, they were stretched into long, looping arcs, their stars now orbiting as a permanent, silent testimony to their violent assimilation. This process reveals a fundamental truth about the universe. Galaxies are not static islands, but dynamic, evolving creatures in a constant state of growth and collision. Andromeda's extended halo, a vast, diffuse sphere of ancient stars surrounding its main disk, is a graveyard filled with the remnants of dozens of these galactic meals. This cosmic cannibalism is not just a history lesson, it is a glimpse into our own future. The Milky Way is on a collision course with the Andromeda Galaxy, and in about 4 billion years, the two giants will meet. The result will not be a catastrophic explosion, but a slow, majestic dance of gravity, a merger that will ultimately form a new, larger galaxy, often nicknamed Milkomda. Our familiar night sky will be utterly transformed, filled with the brilliant, chaotic light of new star formation. So when you look up at Andromeda, you are not just seeing another galaxy, you are staring at the future destroyer and partner of our own cosmic home. A reminder that even the grandest structures in the universe are locked in an eternal, gravitational dance of creation and destruction. While galactic cannibalism unfolds over billions of years, some stellar violence is far more direct and explosive. Zeta Ophiuchi is a stellar cannonball, a runaway star blazing through space at an almost unbelievable speed. This blue giant is not drifting peacefully, it is rocketing through the cosmos at over 60,000 miles per hour. Its journey creates a scene of breathtaking beauty and immense power. As it plows through the dense clouds of interstellar gas and dust, it acts like a speedboat racing across a cosmic sea. The star's intense radiation and powerful stellar wind slam into the material ahead of it, piling it up into a colossal wave. This wave, glowing with intense heat and light, forms a brilliant, arcing structure called a bow shock, a shimmering, fiery shield that stretches for light years in front of the speeding star. But how did Zeta Ophiuchi get launched on this solo journey at such a ferocious velocity? Astronomers have pieced together a dramatic backstory. They believe this star was not always alone. It was once part of a binary system, gravitationally bound to an even more massive partner. That partner, however, lived fast and died young, ending its life in a cataclysmic supernova explosion. When a star goes supernova, the explosion is so asymmetrical and violent that it can literally kick the surviving companion star away with tremendous force, like a slingshot firing a stone. In an instant, Zeta Ophiuchi was set free, catapulted from its original home, and sent careening across the galaxy. This stellar fugitive is now doomed to a lonely existence, forever racing through the void, its brilliant bow shock a permanent testament to the day its partner died and sent it flying. From the fiery wake of a runaway star, we find a structure of such perfect geometry it seems crafted by intelligent design. The Red Rectangle Nebula is a cosmic anomaly, a dying star system that has chosen to sculpt its final breath into the shape of a glowing, blood-red box. Most nebulae are chaotic clouds, the beautiful but messy aftermath of stellar death. This one is different. Through our most powerful telescopes, it appears as a vast, symmetrical X, its four arms connected by faint, luminous lines that give it the unmistakable outline of a rectangle hanging in the void. This precise form is not a sign of alien architects, but a spectacular illusion created by the unique dynamics of a binary star system at its core. Here, two aging stars orbit one another in a tight, gravitational embrace. One of them has exhausted its nuclear fuel and is shedding its outer layers into space. Normally, this expelled gas would billow outward in all directions, forming a standard spherical nebula. But the presence of the companion star and a thick, dense disk of dust surrounding both stars forces this outflow into a completely different shape. Think of two giant ice cream cones placed tip to tip with the dying star at the very center. The dense dust disk acts like a belt around the star's middle, blocking the gas from expanding sideways. The only escape for the stellar material is out through the openings at the top and bottom of this cosmic hourglass. As the gas surges out along these polar axes, it creates two opposing cones or lobes of glowing matter. From our vantage point on Earth, we are looking directly at the side of this hourglass structure. The edges of the cones, where the gas is thickest and brightest, form the two diagonal lines of the X. The fainter lines that complete the rectangle's shape are rungs, like the rungs of a ladder, created by pauses or pulses in the star's outflow over thousands of years. This celestial light show is tragically temporary. The central star is rapidly evolving toward its final state as a white dwarf, and in just a few thousand more years, it will become hot enough to make the surrounding gas glow so brightly that the delicate rectangular structure will vanish, leaving behind a more common planetary nebula. We are witnessing a fleeting masterpiece, a rare and beautiful alignment of physics and perspective that gives us a perfect geometric shape from the chaos of stellar death. It is a reminder that the universe can create its own art with the laws of physics as its only brush. A different kind of stellar killer lurks in the depths of space, a cosmic vampire known as the Black Widow pulsar. This particular pulsar, the super-dense, rapidly spinning corpse of a massive star, is not drifting alone. It is locked in a lethal gravitational embrace with a smaller, cooler companion star, and it is systematically devouring it. The pulsar bombards its partner with relentless beams of high-energy radiation and a furious wind of charged particles, effectively cooking the star and blasting its material away into space. The process is so efficient and so violent that astronomers have named this entire class of objects after the Black Widow spider, a creature known for consuming its mate. This is not a quick death, but a slow, cosmic disassembly that can last for millions of years. The companion star is slowly being evaporated, its outer layers stripped away atom by atom, leaving behind a progressively smaller and more degraded remnant. For scientists, this grim process is a gift. The intense environment around a Black Widow system acts as a natural laboratory for studying physics under conditions impossible to recreate on Earth. By observing how the pulsar's radiation tears at the companion star, they can measure the pulsar's powerful magnetic fields, understand the composition of its particle winds, and test the limits of Einstein's theory of relativity. These binary systems provide a front-row seat to the final, dramatic chapters of stellar evolution, showing us how gravitational relationships can turn from a dance into a death sentence. The Black Widow pulsar is a stark reminder that in the universe, even the bonds between stars can be a source of ultimate destruction. After the predatory dance of black widows and cannibal galaxies, we find a celestial structure of such serene perfection it seems almost impossible. Hoag's object is a galaxy that defies the typical spiral or elliptical forms, appearing instead as a flawless cosmic donut. At its heart lies a brilliant, dense sphere of ancient yellow stars glowing like a single colossal sun. This core is encircled by a perfectly detached, vibrant ring of younger, hotter blue stars with a gap of seemingly empty black space between them. It is a sight of breathtaking symmetry, a structure so geometrically pure it looks more like a piece of galactic art than a naturally occurring island of stars. The mystery of its formation is as profound as its beauty. Most ring galaxies are created by a direct bullseye collision, where one galaxy punches through the center of another, sending ripples of stars and gas outward to form a temporary ring. But Hoag's object shows no signs of such a violent past. There is no second galaxy, no trail of stellar debris, no evidence of a recent cosmic crash. Its two distinct parts, the old yellow core and the young blue ring, exist in perfect separate harmony, leaving astronomers to wonder how such a thing could ever have come to be. One leading theory suggests a very different kind of genesis. Billions of years ago, it might have been a more common, barred spiral galaxy. Then, a gravitational instability could have caused the outer arms to detach and slowly reform into that perfect circle, while the central bulge remained intact. Another possibility involves the ancient accretion of a completely separate, gas-rich dwarf galaxy that was captured and then stretched into a star-forming ring around the older core. Whatever the cause, Hoag's object stands as a stunning anomaly, a solitary and peaceful masterpiece in a universe often defined by chaos and collision. It challenges our understanding of galactic evolution, proving that the cosmos holds pockets of unexpected and serene order waiting to be discovered. From the serene geometry of Hoag's object, we plunge into a mystery that defies all geometry, a star whose light flickers in ways that should be impossible. KIC 8462852, better known as Tabby's star, has become one of the most debated objects in modern astronomy. Located over 1,000 light-years away, this otherwise ordinary star behaves in an extraordinarily strange way. Most stars exhibit tiny, regular dips in brightness when planets pass in front of them, but Tabby's star is different. Its light does not gently dim, it plummets sometimes by as much as 22% in chaotic, unpredictable, and deeply asymmetric patterns. These are not the clean, repeating signals of orbiting worlds, but something far more bizarre and immense, as if vast, irregular shapes are drifting in front of the star, blocking its light. When the data was first released, one hypothesis captured the public imagination like no other. Could we be witnessing the construction of a Dyson sphere, a colossal swarm of energy-collecting structures built by an advanced alien civilization? The notion of a star partially encased by alien megastructures was a thrilling, if terrifying, possibility. Scientists, however, immediately set to work on more natural explanations. The leading theory for years involved a giant, fragmented swarm of comets, stirred up by a passing star, creating a dense cloud of dust and ice that periodically obscures our view. More recent and detailed observations have pointed towards something else entirely: fine, microscopic dust. This interstellar dust is not evenly distributed, but clumpy and opaque, and it is this dust, not solid megastructures, that seems to be the primary culprit for the dimming. Yet even this explanation is not entirely satisfying. The precise nature and origin of this incredible amount of dust remains a puzzle in itself. Where did it all come from, and what process could create such irregular, deep, and long-lasting dimming events? The star itself shows no other signs of unusual activity, making the dusty explanation feel almost as strange as the alien one. Tabby's star stands as a powerful reminder that the universe is under no obligation to make sense to us. It is a cosmic detective story where the clues point in multiple directions, a celestial enigma that continues to challenge our assumptions and fuel our wonder about what is really possible out there in the dark. While we search for answers around one strange star, a completely new type of stellar elder has been discovered hiding in plain sight. Near the crowded core of our galaxy, astronomers have found ancient red giants they call old smokers. These stars are the cosmic equivalent of quiet grandparents who suddenly and without warning exhale vast clouds of dark, obscuring dust into space. For decades, these stars can be perfectly calm and stable, showing no signs of unusual activity. Then, without any clear trigger, they erupt, dimming so dramatically they almost vanish from view as they shroud themselves in a self-made cosmic smog. This is not the violent explosion of a supernova, but a slow, deep, phlegmatic cough from a star in its final years. The significance of this strange behavior stretches far beyond the stars themselves. Scientists now believe these geriatric giants could be crucial contributors to the cosmic ecosystem. The dense clouds they puff out are rich with complex elements forged in their nuclear furnaces, particles that will eventually become the building blocks for new stars, planets, and even life itself. For a long time, we thought we understood the main ways heavy elements were distributed across the galaxy through supernova and stellar winds. The old smokers present a third, more mysterious pathway. Their location in the galactic center, a region dense with stars and potential planets, means they could be seeding that entire environment with the raw materials for creation. This discovery forces us to reconsider the life cycle of the most common stars in the universe and their quiet, pivotal role in the chemical enrichment of the cosmos. They are not dramatic killers but subtle recyclers, and their hidden contributions have been going on right under our noses, or rather telescopes, for billions of years. Our galaxy is not drifting aimlessly through the cosmos. It is on a journey, pulled by an unseen force toward a destination we cannot clearly see. This mysterious gravitational anchor is known as the Great Attractor, a colossal anomaly in intergalactic space with the mass of tens of thousands of Milky Way galaxies. It exerts such a powerful pull that our entire local group, along with thousands of other galaxies, is flowing toward it in a vast cosmic river. Yet for decades, this gravitational titan remained one of the universe's most frustrating puzzles, not because it was too distant, but because it was hiding in plain sight. The Great Attractor lies in the direction of the constellation Centaurus, a region of the sky that is obscured by the dense, bright, and dusty plane of our own Milky Way galaxy. Astronomers call this area the Zone of Avoidance, a name that perfectly captures the observational nightmare it presents. Trying to see the Great Attractor from Earth is like trying to spot a distant mountain range through a thick, blinding fog bank. The countless stars, gas clouds, and cosmic dust of our own galactic disk block almost all visible light, X-rays, and other forms of radiation coming from the other side. For a long time, all we had was the evidence of the pull itself, a mysterious motion that defied explanation. How do you map an object you cannot see? The breakthrough came with new tools that could peer through the obscuration. Radio telescopes which can detect wavelengths that cut through the dust, and infrared observatories which see the heat glow from behind the clouds began to paint a picture. They revealed that the Great Attractor is not a single, monstrous entity, but the dense heart of a gigantic supercluster of galaxies, a gravitational focal point known as the Laniakea supercluster. Our Milky Way is merely a suburban outpost on the outskirts of this immense cosmic metropolis, flowing inward toward its bustling core. So the Great Attractor is not a mysterious void or an alien machine, but the collective gravity of an entire neighborhood of the universe, a reminder that even on the grandest scales, we are all connected by the invisible, relentless pull of gravity. While our galaxy is pulled toward an unseen attractor, Saturn's rings hold a tiny secret of their own. Orbiting the gas giant is a small, clumpy object that astronomers have affectionately named Peggy. This is not a fully formed, spherical moon, but something far more fleeting and rare, a moon caught in the very act of being born. We are witnessing the earliest stages of a celestial body's formation, a process that typically unfolds over millions of years, happening right now at the edge of Saturn's brilliant rings. Peggy was first spotted by the Cassini spacecraft in 2013, appearing as a slight disturbance, a tiny bump, and a corresponding arc of light on the outermost edge of the ring. The rings themselves are a dynamic, bustling environment, filled with countless icy particles constantly colliding and coalescing. Under the right conditions, these particles can begin to clump together, their collective gravity slowly drawing in more and more material. Peggy seems to be one of these lucky accumulations, a growing snowball held together by its own weak gravity and the complex forces within the ring. Its informal name comes from the brother-in-law of the scientist who discovered it, a personal touch for a profoundly impersonal cosmic event. What makes Peggy so extraordinary is the snapshot it provides. We have long theorized that moons form from the disks of material around planets, just as planets form from disks around stars. But to see a potential moon in this fragile, transitional state is like stumbling upon a butterfly just as it emerges from its chrysalis. The object is tiny, perhaps only a half-mile across, and its future is deeply uncertain. It may continue to gather mass and slowly migrate away from the rings, eventually becoming a proper, independent moon. Or more likely, the delicate forces holding it together could fail, and the gravitational pull of Saturn and its larger moons might tear Peggy apart, its constituent particles scattering back into the ring from which it came. This cyclical dance of creation and destruction is likely a constant, ongoing process within the ring system. Peggy is simply one we were fortunate enough to catch in the act. It reminds us that the universe is not a static museum of finished objects, but a vibrant workshop where new worlds are constantly being assembled and dismantled before our very eyes, if we only know where to look. While Saturn's rings whisper of cosmic birth, another stellar rhythm echoes across the light years. Some stars beat with a literal pulse, their light rising and falling in a pattern that looks exactly like a human electrocardiogram. Astronomers call them heartbeat stars, and their existence reveals the hidden forces at work within binary systems. These are not single, solitary suns, but pairs locked in a close, elliptical dance around each other. As they orbit, the distance between them constantly changes, and this fluctuating proximity creates a spectacular gravitational tug-of-war. When the stars swing close together, their immense gravity stretches each one, pulling them out of their normal spherical shape and into a more oval, football-like form. This tidal stretching is so powerful it actually changes the amount of light the star emits, making it appear brighter. Then, as the stars swing apart, the gravitational grip relaxes and the stars settle back into their rounder shapes, dimming slightly. The result is a beautifully predictable, repeating pulse in brightness, a cosmic heartbeat recorded across thousands of light years. But the rhythm tells us more than just the star's orbital period. By studying the precise shape of this light curve, the sharp peaks and gentle valleys, scientists can perform a kind of stellar echocardiogram. They can probe the internal structure of these distant suns, measuring their density, their internal vibrations, and even how their mass is distributed from core to surface. This data is invaluable, providing a direct test for our models of how stars work under extreme stress. These celestial heartbeats are a powerful reminder that even the most fundamental forces, like gravity, can create patterns of breathtaking regularity and beauty, turning the chaos of orbital mechanics into a rhythmic dance of light and shadow in the void. Gravity's pull does not end with the great attractor. Astronomers have detected something far more unsettling, a mysterious current carrying entire clusters of galaxies on a journey toward the edge of everything we know. They call this phenomenon the dark flow. By meticulously tracking the motion of thousands of galaxy clusters, scientists noticed a faint but consistent drift, a collective stream moving at an incredible speed toward a single, specific point on the cosmic map. This is not the random motion of an expanding universe, but a coordinated march, as if an immense, unseen hand is guiding them. The most shocking part is the direction of this flow. It points toward a region of space that lies beyond the cosmic horizon, beyond the farthest light we can ever hope to see. The observable universe is the portion of the cosmos from which light has had time to reach us since the Big Bang, a bubble roughly 93 billion light-years across. The dark flow suggests that something immense, something with gravitational power on a scale we can barely comprehend, exists outside of that bubble, pulling on everything inside. What could possibly exert such a force from beyond the edge of our reality? The leading theories are as profound as they are speculative. One incredible possibility is that we are feeling the gravitational tug of another universe entirely, a separate cosmic domain residing in a vast multiverse. Just as the moon's gravity creates tides on our oceans, a neighboring universe of immense size could be creating this cosmic tide, pulling our entire universe along with it. Another idea posits a vast, primordial irregularity in the fabric of space-time itself, a relic from the first moments of creation that set this inexorable flow in motion. Both explanations challenge the foundational principle that the universe on the largest scales should be uniform and isotropic, meaning it should look the same in all directions. The dark flow hints that our cosmic home is not a solitary island, but perhaps just one piece of a far grander and far stranger reality. It forces us to confront the humbling possibility that the entirety of our observable cosmos, with its hundreds of billions of galaxies, might merely be a single leaf caught in a river whose source we can never see. Drifting through the constellation of Cassiopeia, a faint, ethereal form glows with a spectral light. This is the Ghost Nebula, officially catalogued as IC63, a vast cloud of hydrogen gas and dust being sculpted by a cosmic force of nature. Its haunting shape, billowing like a phantom's cloak, is not a sign of malevolence but a beautiful and temporary side effect of stellar violence. The ghost is being haunted itself by a star so brilliant and powerful it is literally tearing the nebula apart. That star is Gamma Cassiopeiae, a blue-white subgiant that outshines our sun by tens of thousands of times. This stellar monster unleashes a hurricane of ultraviolet radiation, and that relentless energy is what gives the ghost its glow while simultaneously eroding it. The process is a delicate and destructive ballet. The intense radiation from Gamma Cassiopeiae slams into the cloud, energizing the hydrogen atoms and causing them to emit their own characteristic red light. This is what we see as the nebula's faint, shimmering form. At the same time, this stellar wind acts like a cosmic sandblaster, pushing the gas and dust away, slowly dissipating the ghostly structure into the void. We are witnessing a celestial evaporation, a structure that will ultimately fade from view as its material is scattered across interstellar space. This beautiful phantom is a transient monument, a fleeting work of art painted onto the cosmos by the unforgiving brush of a nearby star. It serves as a poignant reminder that some of the universe's most stunning sights are not permanent, but brief, brilliant moments in an endless cycle of creation and dissolution. Deep within the constellation Hercules, a lonely object pulses with a rhythm that baffles every expert who observes it. Known only by its catalogue number, LSRJ 1835 plus 3259, this enigmatic body defies classification. It emits a blast of radio waves every 20 minutes with such precision and power that it acts like a lighthouse for the entire galaxy. Yet no one knows what kind of celestial engine could possibly be responsible. Its discovery was a complete accident stumbled upon during a sky survey for faint, cool stars, and its signal was so bizarre it stood out immediately. This was not the rapid, millisecond ticking of a pulsar, nor the steady glow of a main sequence star. It was something entirely new, a slow, powerful beacon flashing from the cosmic dark. The object is too faint to be a pulsar in the traditional sense, and its magnetic field, while strong, is thousands of times weaker than that of a magnetar, another type of highly magnetic stellar corpse. It sits in a strange and lonely place on the chart of stellar objects, fitting into no established category. One of the most compelling and unsettling theories is that we may be looking at an ultra-long period magnetar. This would be a type of neutron star that rotates so slowly its pulses are separated by hours instead of fractions of a second. If this is true, it suggests an entirely new, hidden population of these slowly spinning dead stars, their faint, infrequent pulses making them incredibly difficult to find. Another, even more exotic possibility is that this is a white dwarf pulsar. White dwarfs are the Earth-sized cores of dead sun-like stars, and while they are incredibly dense, they are far less dense than neutron stars. The idea of a white dwarf spinning fast enough to generate such a powerful, periodic radio signal pushes the limits of what we believe is physically possible for such an object. This single, lonely beacon forces astronomers to question the boundaries of their own definitions. Is it a stellar corpse we have never seen before, or a known type of star behaving in a way we never predicted? Every flash from LSRJ 1835 plus 3259 is a reminder that our maps of the cosmos are still incomplete, and that the strangest discoveries are often the ones that do not fit any of the boxes we have prepared for them. The universe loves to blur the lines we create to make sense of it, and nowhere is this more apparent than with a strange object known as Elst Pizarro. Officially designated an asteroid, this resident of the main belt between Mars and Jupiter follows a perfectly circular, rocky path, just as an asteroid should. Yet, on 3 separate occasions, astronomers have watched in astonishment as it suddenly and unpredictably sprouted a faint, dusty tail, transforming itself into the spitting image of a comet. It is a celestial schizophrenic, an object that cannot seem to decide what it wants to be. How can a simple space rock suddenly become a glowing visitor with a tail? The answer appears to lie not in its orbit, but in its composition. Scientists now classify Elst Pizarro as an active asteroid, a rare hybrid that behaves like a dormant rock until something triggers it to life. The leading theory is that this object is a kind of icy fossil, a rocky body that somehow retained a subsurface reservoir of water ice from the earliest days of the solar system. Most asteroids in the main belt are baked dry by the sun, but Elst Pizarro may have been lucky, perhaps protected by a thick, dark crust of dust and rock. The transformation begins when a small impact, a micrometeorite strike, or the stress of its own rotation, cracks open this protective shell. Suddenly, the hidden ice is exposed to the vacuum of space and the sun's faint warmth. In an instant, the ice does not melt but sublimates, turning directly from a solid into a gas. This jet of vapor erupts from the surface, carrying with it a cloud of fine dust and grit, which then expands outward, pushed by the gentle pressure of sunlight to form the temporary, ghostly tail we observe. This single object forces us to rethink our entire catalogue of the solar system. We have long divided small bodies into 2 neat categories: icy comets from the outer darkness and rocky asteroids from the inner belt. Elst Pizarro proves that this division is artificial. It suggests that the early solar system was a messy place, with material from different regions mixing together, leaving behind trapped relics like this one. What other dormant comets are masquerading as ordinary asteroids, hiding their icy secrets just beneath a stony surface, waiting for a chance collision to reveal their true nature? Geometry finds its ultimate expression in the cosmos with the Red Square Nebula. Known to astronomers as MWC 922, this structure is not merely rectangular. It is an almost flawless square of glowing gas and dust, a blood-red frame hanging in the void with a brilliant star at its very center. Its symmetry is so precise it looks engineered, as if a cosmic architect drafted it with a ruler and compass. This perfection emerges not from design, but from a violent and beautiful stellar process. The prevailing theory suggests the square is an optical illusion created by a pair of conical outflows. Picture two immense, hollow ice cream cones placed tip to tip, with the central star nestled at the narrow point where they meet. These cones are not solid, but are the boundaries of powerful winds ejected from the star's poles. We are viewing this hourglass structure directly from the side, looking straight at its equator. The rims of the two cones, where gas and dust are concentrated and glow the brightest, form the two long, diagonal lines of an X. The stunning part is the faint, connecting lines of light that complete the square shape. These are thought to be echoes or reflections within the outflow, perhaps from brief, intense pulses of material ejected by the star at regular intervals, creating a ladder-like effect within the conical cavities. This creates the fleeting, breathtaking impression of a perfect geometric figure. The nebula's intense red color comes from hydrogen gas, energized by the fierce ultraviolet light of the central star. What makes the red square so special, even compared to other bipolar nebulae, is our nearly perfect equatorial vantage point and the remarkable density and symmetry of its outflows. This specific alignment gives us a front-row seat to a masterpiece of physics, a temporary sculpture that will eventually dissipate as the star evolves. It stands as a profound reminder that the universe's underlying laws can produce an order so perfect it feels intentional, a square of cosmic light born from the chaos of a star's death throes. Speculation about alien intelligence often begins with a search for their energy sources. A star known as TYC 6111-1162-1 has become a prime candidate for such a search, a sun that radiates a strange and unexpected signature of heat. Its visible light appears normal, but it is also glowing with a powerful and unexplained excess of infrared radiation. This specific type of energy is the telltale heat of waste energy, the kind that would be shed by any vast technological structure absorbing starlight. The most famous theoretical construct for such a feat is the Dyson sphere, a hypothetical swarm of energy collectors built by a civilization so advanced it could encase its entire star to power its endeavors. The idea is that over time, a growing civilization would need more and more power, and the most logical step would be to capture every last photon from its home sun. This star's unusual infrared glow fits that profile perfectly, suggesting the presence of something massive and warm, but not as hot as the star itself, orbiting in its vicinity. It is a clue that ignited the imagination of astronomers and the public alike. Yet before we declare the discovery of a Type 2 civilization, science demands we exhaust every natural explanation. The leading alternative is far less dramatic but equally fascinating. This star could be surrounded by a colossal, warm ring of cosmic dust, perhaps the remnants of a cataclysmic planetary collision that occurred in the relatively recent past. Such an event would pulverize worlds into a fine, opaque debris field, which would then absorb the star's light and re-radiate it as the exact kind of infrared excess we observe. This dust would need to be positioned at just the right distance from the star to be warmed to the observed temperature, creating a perfect, if tragic, natural mimic of an alien megastructure. The true power of this discovery lies not in confirming one theory over the other, but in demonstrating the rigorous process of astroarchaeology. We are learning to sift through the light of distant suns, looking for the subtle fingerprints of both cosmic catastrophe and just possibly cosmic engineers. TYC 6111-1162-1 remains an enigma, a celestial riddle that forces us to ask where the line lies between a universe that is merely strange and one that is truly inhabited. The hunt for a hidden giant is reshaping our understanding of the solar system's outer limits. Far beyond the orbit of Neptune, in the frigid darkness of the Kuiper belt, a population of small, icy objects is behaving strangely. Their orbits are not randomly scattered as we would expect. Instead, they are mysteriously clustered, their elongated paths all pointing in roughly the same direction and tilting in the same way, as if an unseen shepherd is herding them. The gravitational force required to orchestrate this cosmic dance is immense, pointing to one startling conclusion. A massive, undiscovered planet, up to 10 times the mass of Earth, must be lurking in the distant gloom. This hypothetical world is known as Planet 9. If it exists, its proposed orbit is staggeringly large, taking between 10 and 20,000 years to complete a single journey around the Sun. At its most distant point, it would be so far away that our Sun would appear as little more than an especially bright star in its sky. The search for this elusive world is a monumental challenge. It is not a matter of simply pointing a telescope at a patch of sky. Planet 9's orbit is only roughly mapped, a vast swath of potential space it could occupy. Compounding the difficulty, a planet at that distance reflects very little sunlight, making it incredibly faint. Astronomers are using some of the world's most powerful telescopes, painstakingly comparing images taken weeks or months apart, looking for one tiny, slow-moving dot of light against a backdrop of millions of stationary stars. Each potential candidate must be tracked to confirm its motion, a process of elimination that has so far come up empty. Yet the gravitational evidence remains compelling, a ghostly signature written in the paths of distant ice dwarfs. The discovery of Planet 9 would be a moment of profound humility, revealing that our own cosmic backyard still holds giants we have yet to meet. Its path was the first sign that this traveler was not from here. In October 2017, a Canadian astronomer named Robert Warwick spotted a tiny dot of light moving at tremendous speed through our solar system. Its trajectory was not a closed loop around the Sun, but a steep, open-ended hyperbola. This could mean only one thing. The object, soon named Oumuamua, was an interstellar visitor, the first ever confirmed to pass through our cosmic neighborhood. It was a rock from another star, a messenger from the vast gulf between suns. As telescopes around the world swiveled to track it, the strangeness only deepened. The object was already on its way out, moving too fast to be captured by the Sun's gravity, giving astronomers only a few precious weeks to study it. The most startling feature was its shape. By measuring how its brightness changed as it tumbled through space, scientists calculated that Oumuamua was not round nor even lumpy. It was profoundly elongated, shaped like a giant cosmic cigar or a pancake, with its length estimated to be up to 10 times greater than its width. Nothing in our solar system looks quite like that. The oddities did not stop there. As Oumuamua sped away from the Sun, its velocity was being minutely tracked. The laws of gravity alone dictated exactly how fast it should be moving, but the object was defying them. It was accelerating just slightly, as if an invisible hand was giving it an extra push. This is known as non-gravitational acceleration, and it sparked a fierce scientific debate that continues to this day. The most conventional explanation points to outgassing. When a comet approaches the Sun, its ices heat up and turn to gas, which jets out from the surface like a natural rocket engine. This jetting can provide exactly the kind of push astronomers observed. The problem was that no one ever saw a coma or a tail, the classic cloud of gas and dust that surrounds a comet. Was Oumuamua a comet after all, but one made of such unusual, pure ices that it released only a faint, invisible gas that left no dusty trail? Or was it something else entirely, a new class of object we had never encountered before? The lack of a visible coma led one prominent astronomer, Avi Loeb, to propose a far more exotic possibility. Could Oumuamua have been an artifact of an alien civilization, perhaps a discarded piece of a broken spacecraft or a light sail, a thin, artificial object pushed by the radiation pressure from starlight? The scientific community largely remained skeptical, favoring natural explanations, but the very fact that the hypothesis was taken seriously underscores how truly bizarre this visitor was. Oumuamua forced us to confront the limits of our knowledge. It was a real-time lesson that when we finally get to examine a piece of another star system, it might not look anything like what we have at home. It has already vanished back into the interstellar dark, a fleeting, enigmatic postcard from a place we may never visit, leaving behind only a trail of questions and a profound sense of cosmic wonder. Our cosmic tour now leads us to a ghost, a galaxy that is not there. AGC 114905 appears in our telescopes as a faint, wispy smudge, a cloud of gas the size of a full-fledged galaxy, but with a stunning and profound emptiness. It is a dark galaxy, an object whose very existence seems to defy logic. By all rights, this collection of matter should have coalesced into billions of shining stars, yet it contains almost none. The handful of stars it does hold are so sparse and lonely that they do little to illuminate the true nature of this cosmic phantom. So what holds this galaxy together? The answer is a colossal amount of dark matter, the invisible, mysterious substance that makes up most of the mass in the universe. This dark galaxy is essentially a massive halo of this unseen material, a gravitational anchor without the glittering city of stars we expect to find. Its discovery forces a fundamental question. How do you make a galaxy without the stars? Our best models of galaxy formation are built on the idea that dark matter acts as a scaffold. Its gravity pulls in normal gas, which then cools, condenses, and ignites into stars. A dark galaxy like this one suggests that for some mysterious reason, this process simply failed. Perhaps the gas was too hot to condense, or maybe it was stripped away by a tidal force early in its history, leaving the dark matter scaffold standing alone, a frame without a picture. This ghostly object is more than just a cosmic curiosity. It is a direct probe into the nature of dark matter itself. By studying its rotation and the motion of its scant visible material, astronomers can map the distribution of the invisible dark matter that dominates it. This provides a unique, almost pure laboratory to test our theories about what dark matter actually is. Does it behave exactly as we predict, or does this dark galaxy hold clues that our models are missing? These faint, starless giants challenge our understanding of how the universe builds its largest structures, reminding us that the cosmos is filled not only with what shines, but with the profound and dominant presence of what remains forever in the shadows. The Methuselah star shines as a lonely sentinel in the constellation of Libra, a stellar relic that once threatened to rewrite the entire history of the cosmos. Its official designation is HD 140283, but its nickname reveals its true nature. Initial measurements of this ancient star suggested it was a staggering 16 billion years old. This created a profound paradox because the universe itself is only calculated to be about 13.8 billion years old. How could a star be older than the universe that gave it birth? This was not a simple rounding error, but a crisis for our fundamental models of physics. The star's extreme age was written in its chemical makeup. It is a population 2 star, meaning it is composed almost entirely of hydrogen and helium, with only the faintest traces of heavier elements. This purity marks it as a second-generation star, formed from the primordial gas clouds enriched by the very first generation of stellar giants that lived, burned fast, and died in spectacular supernova. To be so metal-poor, it had to be ancient. The resolution to the age paradox came not from discarding the star's antiquity, but from refining our measurements with breathtaking precision. Using data from the Hubble Space Telescope, astronomers painstakingly narrowed the star's distance, which in turn refined calculations of its intrinsic brightness and its stage of life. They incorporated subtle new understandings of the star's oxygen content and its internal structure. The revised age settled at around 14.5 billion years, a figure that still brushes uncomfortably close to the age of the universe, but now sits within the margin of error. The Methuselah star remains the oldest known star in the cosmos whose age we can reliably measure. It is a time capsule from an era when the universe was young and dark, just beginning to light its first fires. Every photon that reaches us from this ancient sun is a direct messenger from that primordial dawn, a reminder that some of the universe's first children are still with us, their quiet light a chronicle of time itself. Some of the universe's grandest structures are written in invisible ink, visible only when we listen to the cosmos rather than look at it. Drifting through the southern skies, the galaxy Pks 2014-55 appears utterly unremarkable in visible light. But when astronomers tune their radio telescopes to its frequency, a breathtaking secret is revealed. It is a perfect colossal X stretching over millions of light years, as if some cosmic hand signed its initial upon the void. This is not a random scattering of stars, but the ghostly aftermath of a violent reorientation, a celestial pivot of unimaginable scale. The artist behind this enormous signature is the supermassive black hole lurking at the galaxy's heart. These gravitational monsters are not passive. They often fire out twin jets of superheated plasma at nearly the speed of light, typically in two opposing straight lines. For Pks 2014-55, something dramatic interrupted this process. The prevailing theory suggests that the central black hole experienced a major merger, colliding and combining with another supermassive black hole. Such a cataclysmic union would have caused the spin axis of the newly formed, more massive black hole to suddenly flip or wobble. In an instant, the direction of its powerful jets would have changed, pointing in a new direction. What we see as the X is the fossil record of this event. The two long, fading arms of the X are the ancient jets, the original direction of outflow that has since been powered down. The two shorter, brighter arms are the new, active jets, blazing along the freshly established axis. We are witnessing a moment of cosmic whiplash frozen in time, a testament to the fact that even the most powerful forces in the universe can be thrown off course. This celestial X marks the spot of a past cataclysm, a permanent scar in the fabric of space that tells a story of collision, realignment, and the enduring power of a black hole's rage. And so we reach the final entry on our list, a mystery that began not with a telescope's image, but with a single word scribbled on a data printout. The WOW signal is perhaps the most famous radio signal in history, a powerful burst of energy that lasted for 72 seconds and then vanished forever. It was detected in August 1977 by the Big Ear radio telescope in Ohio, a routine scan of the sky as part of the search for extraterrestrial intelligence. The signal was so intense and so perfectly structured that when astronomer Jerry Amon saw the alphanumeric code representing its strength, he circled the sequence and wrote one word in the margin: WOW. The signal was narrowband, concentrated on a specific frequency that hydrogen atoms naturally emit, a logical choice for any civilization trying to announce its presence across the interstellar void. It came from the direction of the constellation Sagittarius, rose and fell in a perfect curve as the Earth's rotation swept the telescope's field of view across it, and then it was gone. Despite decades of repeated searches targeting the same patch of sky, it has never been heard again. The hunt for a natural explanation has been relentless. Could it have been a signal reflected off a piece of space debris, perhaps a discarded satellite or rocket booster? The frequency used makes that incredibly unlikely, as it is protected internationally, reserved exclusively for radio astronomy. Comets were once proposed as a culprit, but the specific comets in that region at that time were not emitting at the right frequency. There is no known stellar phenomenon, no pulsar or black hole, that produces such a brief, powerful, and isolated burst on that specific bandwidth. The signal's transient nature is the core of the puzzle. If it was a deliberate broadcast, was it a one-time beacon, a fleeting hello cast into the cosmos? Or was it a continuous signal that we simply happened to drift through for one precious minute, like a ship passing through a stationary lighthouse beam? The wow signal stands alone, a singular event that has never been replicated. It is the ultimate cosmic teaser, a whisper that fits the profile of an intelligent call more closely than any other signal before or since. It remains the best candidate for a message we were not meant to hear, a ghost in the radio static that continues to ask us the most profound question of all. In a universe of strange objects and violent forces, are we truly the only ones listening? The universe has revealed itself as a gallery of the bizarre, from stellar vampires to phantom galaxies and whispers from the void. Each of these 25 objects, from glittering diamond worlds to the silent scream of the wow signal, stands as a monument to cosmic creativity. They prove that reality routinely outstrips our wildest science fiction, offering puzzles that defy simple explanation and ignite our deepest curiosity. This relentless strangeness is not a barrier to science, but its very engine. Every mystery, every anomaly that does not fit our models pushes us to look deeper, think harder, and build better tools to listen to the cosmos. It reminds us that wonder is not the enemy of understanding, but its most vital fuel. The universe is under no obligation to make sense to us, and that is what makes its exploration the greatest adventure of all. We want to hear which of these cosmic oddities captured your imagination. Was it the perfect geometry of the Red Square Nebula, the terrifying emptiness of the Boötes Void, or the lonely pulse of that unclassifiable beacon? Tell us your favorite strange space object in the comments below, and subscribe to join us on our next journey into the mysteries of the cosmos.